Liquid is pouring into a container at a constant rate of 20 cm3 per second. So if this is the container, so liquid is pouring in. So dV by dt, this is 20. And it is pouring out, leaking out. So liquid is pouring out, so negative rate. So dV by dt. And it is proportional to the volume. That means kV. Proportional means multiplied by a constant. So the overall rate is going to be the difference of the rate. So question number A. Liquid pouring in is dV by dt equals to 20 cm3 per second. Liquid pouring out is negative rate minus dV by dt is proportional to V. So dV by dt is 20 minus kV. So that is the overall rate. So the main question is solving the differential equation. So we have to use again the separable method. So dV, so we can take all the V terms on one side. So this will be 20 minus kV, and this is dt. So integrate both sides. So this is going to be ln. Reciprocal of a linear expression is ln. So 20 minus kV divided by the chain rule. So d by dv of 20 minus kV is minus k, and this is 1 dt. So that should be t plus c. Now this is the general solution of the differential equation, but we have this information. Container is initially empty. Empty means V equals to 0. Initially means T equal to 0. So initially means T equal to 0. Empty means V equal to 0. This two information is given. So we can write when V equals to 0, T equals to 0. So it should be ln 20 divided by minus k equals to 0 plus c. So we know the value of c. So this becomes a particular solution. Therefore, ln 20 minus kV divided by minus k equals to t minus ln 20. So we can multiply both sides with minus k. So that would be ln 20 minus kV equals to minus k t minus ln 20 by k, and that would be minus kt minus minus plus ln 20. Therefore, we can convert the ln into e. So 20 minus kV equals to e to the power minus kt plus ln 20. This is a pretty tricky sum. You have to be very careful so that there is no mistake. It's very lengthy also. So this is going to be e to the power ln 20 is 20. So 20 e to the power minus kt. Let me mention the rules that we have been using over here. Here what we did is we multiplied with minus k, and then here we use the rule e to the power ln x equals to x. So we write 20 over here. From here to here we wrote x to the power a plus b is the same as x to the power a multiplied by x to the power b. So this is the indices rule. And from this line to this line we use the rule ln x equals to a, therefore x equals to e to the power a. So we are using quite a number of different rules for simplifying this, so that's why it might seem a bit difficult. You have to be very careful. So this is going to be 20 minus 20 e to the power minus kt equals to kv, and if we send the k to the other side, therefore v equals to 20 minus 20 e to the power minus kt divided by k, and we can further simplify it. V equals to 20 by k minus 20 by k e to the power minus kt. So we can say 20 by k is the arbitrary constant a, and minus 20 by k is the arbitrary constant b, and that's what they said. They said express in that format giving the values of a and b in terms of k. So we can write the values in terms of k. So a equals to 20 by k and b equals to minus 20 by k. The final part is given that dv by dt is 10 and t equals to 5. So we need an expression where we have dv by dt, which is the rate of change or derivative, or we can and put the value of t equals to 5. Now the first thing that we have, dv by dt equals to 20 minus kv. We don't have t in this expression, so we cannot use it. Instead, we can use the previous sum that we just did. So we can write this as the derivative is, so if this is v, so we can write v equals to 20 by k, it's a constant, minus 20 by k e to the power minus kt. So the derivative would be dv by dt. So we are differentiating v in terms of t. 20 by k is a constant, so it becomes 0. So minus 20 by k is the coefficient. It would remain 20 by k. E to the power minus kt, the derivative would be the same. Into chain rule, d by dt of minus kt would be minus k. So that turns out to be, this is minus, it becomes plus, and this k cancels. It would be 20 e to the power minus kt. So dv by dt is 10. So at dv by dt equals to 10 and t equals to 5. From here we can write 10 equals to 20 e to the power minus k into 5, and we can find the value of k. So 10 by 20 e to the power minus 5k. So this is half. Therefore we can write minus 5k equals to ln half. And ln half is ln 2 to the power minus 1, which is, if the minus 1 power comes in front, it will be minus ln 2. So this negative and this negative cancels. K equals to ln 2 by 5. So we have found the value of k. So ln 2 by 5. Now what we have to do is find the volume. So we have to find the volume. So we know the formula, and we can put the value when t equals to 10. So find the volume when t equals to 10. So let's get back to the volume expression. So volume equals to 20 by k minus 20 by k e to the power minus kt at t equals to 10 and k equals to 1 by 5 ln 2. We can write volume equals to 20 by ln 2 by 5 minus 20 by ln 2 by 5 e to the power minus k is 1 by 5 ln 2 and t is 10. So we can simplify this and write, so 20 and divided by 1 by 5 is going to be 100 by ln 2 minus 100 by ln 2, and this 5 and this 10 cancels, it becomes 2. So this becomes e to the power minus 2 ln 2. We can write 100 by ln 2 common, and we can write 1 minus e to the power. If we bring the minus 2 as the power of 2, it becomes ln 2 to the power minus 2. It becomes ln 2 to the power minus 2. So this would be 100 by ln 2, which is 1 minus e to the power ln 1 by 4. So 100 by ln 2, 1 minus e to the power ln 1 by 4 is 1 by 4. And let's do it over here. So we can write 100 by ln 2, 1 minus 1 by 4 is 3 by 4. We can cancel this, 4 2s are 8, 4 5s are 10, and this is 75 divided by ln 2. So that's the volume. So this is a pretty lengthy sum, and you have to be very, very careful to do this.